Okay, let's get it. For me, for the day, this is my last video, but for you, you're just getting into it. You'll have a couple more in these. These initial 10-1, 10-2, 10-3, we're trying to teach you the whole dang topic, so there are going to be more videos than you'll see in the rest of them, where once we have these tactics down, we'll actually be able to start utilizing them and doing things with them. Let's go. So we're going to talk about limit laws. You passed Calc 1, didn't you? So we're good as long as you pass Calc 1. I mean, you've already done limits. You already know your limit laws. We're golden. So this should be real simple, right? Real simple. Let's go. So let's determine this limit. Where's it go? Oh, wait. Give it a second. Where's it going? Do you know your limit laws? Because what does it mean to determine the limits of the following sequences? Well, now our terminology means when it says define the limit, we're talking, what's the limit as n tends towards infinity of our a sub n? Oh, so that's the limit as n tends towards infinity. Sorry, my n's start to look like h's. Just know they're an n. Dang. How do we do this? Well, we're trying to find the limit of this whole thing. Anything separated out by a plus or a minus, we already know that. We can just bring our limits in. Come on, man. So we're like, this is the limit as n tends towards infinity of 4 times 0.7 to the n, minus the limit as n tends towards infinity of 1 over 4 to the n. Just using limit laws, we're just, we're just practicing doing that stuff we did in Calc 1 that you've already passed. Now, hey, did you know there's a constant multiple rule? We could remove noise and yank that out to the front. Okay. And then over here, did you know that this is the same thing as 1 to the n over 4 to the n? Therefore, we could just call this 1/4 to the n. Get that trick down. That's what common 1. That happens a lot through this, where you got to recognize that 1 can be 1 to any power. You can choose what it is. And now we're going to use what we learned in the previous videos. The limit as n tends towards infinity of any number trapped between -1 and 1, not including -1, will go to 0. Hey, I'm pretty sure 1/4 is in between -1 and 1. I'm pretty sure 0.7 is in between -1 and 1. Thus, this is equal to 4 times 0 minus 0, which is equal to 0. We just use limit laws in order for us to evaluate. Right? You change those to x's, and this could be on any one of your frickin' tests in a Calc 1 class. Shoot, if you took it with me, this would be some of the easiest frickin' problems you would do in the whole frickin' class. But it makes it challenging because you're learning new topics while having to remember everything you learned in the past. And then actually knowing why you used it and how to use it. It can be challenging. I know I'm minimizing it and talking trash, but it is. We're just building upon things we learned before. And let's just do one more. We'll keep this video short, and then we're going to move into the squeeze theorem. Yeah, there's a squeeze theorem. But we'll just be able to state it. Cool. Does this converge or diverge? Now, I'm just going to give you a little bit of a hint. I'm going to give you a little bit of a hint. I'm going to take it out and put it back. I took that 4 to the n out. I'm going to put it back in a second. Do you see the degree at the top? Do you see the degree at the bottom? Do you see those things? It's 2 and 2. It's going to converge to 1. Okay, cool. And then we're going to divide it by more numbers. I think this will converge. But this isn't the point. We're trying to find the limit. I'm just trying to let you see some patterns. We want to know the limit. As n tends towards infinity. So we're like, okay, cool. Let's do this. And sorry, my n's just continually look like h's. Okay. So let's use some limit laws so we can actually evaluate these limits, because it's not that bad as long as you know your limit laws. I mean, come on, man. We're good. We're good. Well, did you know that this is 1 over 4 to the n times that 3n squared plus n over 3n squared minus 4? We can pull this out. we can pull the 1 over 4 to the n out and then multiply by using those limit laws that we learned in Calc 1. I know that this section gives you like limit laws for sequences. It's the same freaking thing. Yes, there's a couple little slight differences, but not how we do the work. It's the same thing. So now we have the limit as n tends towards infinity, and let's make that 1 to the n. That's 1/4. That goes to 0. I know that goes to 0. Now, as long as this doesn't go to infinity or negative infinity, it doesn't, by the way. Right? Because what's in 0 times infinity? It equals do more work. 0 times negative infinity means do more work. It's not 0. It's not infinity. It's just whatever the frick it is. But I'm no longer doing this anymore. Same degree, top and bottom. That's 1. Sorry. Just writing that in there. I'm not even putting that in. Come on. Degree matches. It's the coefficient over the coefficient. 3 over 3 is 1. Thus, we have, by the geometric sequences, that goes to 0 because 1/4 is in between -1 and 1, not including -1. So we get 0 times 1 is equal to 0, and it converged. It converged. We evaluated it by using limit laws. If we don't have our limit laws down, start. Just start. Begin working on your gosh darn limit laws again. You can send me a message. I will send you, I'll send you some worksheets just on basic limit laws without the series and the sequences in there. Because if we do not have our limit laws down, if we cannot evaluate these, you might as well just take the day off when you take your test on this, because we must be pro. That's not to be a jerk. I want to make sure that we know where we need to be. If you do not have, repeat it. I know repeat. You can just turn me off if you're over it. You don't have your limit laws down? You are not passing this section. So let's make sure that we have our limit laws down. You can do it. You're learning it for the second, third time now? You can get them down. Yeah, buddy. All right, so the next one we're going to go into, we're going to do a little squeeze theorem. And I'll try and make it real basic on you. Make it just simpler than actually having to go through and do all the work. And then we're going to move into a lot of different words and growth rates. And this is a large section. This is like something like 14 pages or something. So there's a lot to go through. And like I said, and then we'll have a big one in 10.3. But once we get past that, they should shorten up. And that's going to be the stuff that'll be on your exam. It'll be after A3. No. All right. See you.